To turn Hitler's obsession into reality and transform the jet into a fully fledged bomber, engineers had to overcome a number of challenges. First off, they needed to test new bomb racks. These had to handle either a pair of 250 or 500 kilogram bombs or a single massive 1,000 kilogram bomb. They also had to figure out the right bomb sight and develop entirely new drop tactics. Interestingly, the pilot could only drop bombs during straight and level flight. Diving was out of the question. The aircraft simply did not have the dive brakes needed to safely pull out of a dive. Releasing bombs in a steep climb was not even an option. All these dangerous payload experiments were carried out on one of the Me-262 prototypes. To help the heavy aircraft get off the ground faster and shorten its takeoff roll, they fitted it with rocket boosters. Each of these produced over 1,100 pounds of thrust. Engineers even looked into a highly unconventional option. They tried towing 500 and 1,000 kilogram bombs. These were fitted with their own small wings and towed behind the airplane on a rigid 23-foot tow bar. To get this bizarre setup off the ground, a special dolly was placed under the bomb. The second the aircraft lifted off, explosive bolts fired to drop the dolly. The bomb itself was released in a shallow dive, and the pilot would aim through a standard gun sight. Naturally, under those conditions, pinpoint accuracy was completely out of the question. Test pilot Gerd Lindner flew these trials. His flights in the Me-262 showed that the concept actually worked, at least in principle. But there was a major catch. Weighed down by a 500-kilogram bomb, the jet could not push past 315 to 330 miles per hour. The real nightmare, though, was towing the massive 1,000-kilogram bomb. Its auxiliary wing severely disrupted the aerodynamics, making the airplane practically unflyable. During one of these test flights, the situation rapidly spiraled out of control. This forced Lindner to bail out, even though they tried to continue the tests with other Me-262s. These attempts consistently ended in serious crashes. Ultimately, the idea of towing winged bombs was scrapped for good. Engineers had given this unusual arrangement its own name, Deichselschlepp, which roughly translates to drawbar tow. The bulk of the flying fell to a single testbed airframe, Me-262 V-10, which had already been damaged once in an Allied air raid on the Leifheim airfield before it was patched up and pressed into this dangerous new role. Flying out of Lechfeld in the closing months of 1944, the aircraft first towed a 500-kilogram bomb aloft in late October. Even at that lighter weight, the rigid boom linking bomb and fighter set up violent porpoising motions that shook the whole airframe, a problem that only grew worse once the heavier 1,000-kilogram weapon was substituted in. A major turning point for the Me-262 came on March 2, 1944. On that day, the Air Ministry handed down a strict order. They had to order an immediate production run of an initial batch of 60 bombers. Alongside the heavy bombs mounted under the fuselage, the aircraft retained part of its fighter armament. This included two powerful 30mm cannons. Effectively, the Germans had built a versatile fighter bomber. It was not just capable of dropping a deadly payload, it could hold its own in a dogfight and take down enemy aircraft. To put the airframe in perspective, a standard Me-262 measured about 35 feet from nose to tail, spanned just over 41 feet across the wings, and weighed somewhere around 9,000 pounds empty. Loaded up with fuel, ammunition, and bombs, that figure could climb past 15,000 pounds, yet the jet could still outrun anything the Allies had in the air. Its remaining 30mm cannons, the Mk-108, fired shells packed with high explosive at a fairly low muzzle velocity, but with such violent effect that just 3 or 4 hits were usually enough to bring down a heavy bomber. The trade-off was a curved, fast-dropping trajectory that forced pilots to hold their fire until they had closed to within a few hundred yards of the target. But ramping up mass production proved to be incredibly difficult. Facing a catastrophic shortage of skilled labor, the factory floors were manned by workers deemed unfit for military service. Equally serious problems cropped up with the Jumo 004 jet engines. At the time, this technology was still in its infancy and required significant refinement. Each Jumo 004B produced only around 1,800 pounds of thrust, a modest figure by the standards of later jet engines, and every one of these power plants weighed well over 1,600 pounds on its own. Its single-stage turbine spun on blades machined from a steel alloy that could never fully substitute for the nickel and chromium called for in the original design. Under the extreme heat of continuous running, these blades gradually stretched, a flaw engineers referred to as creep. Once a blade lengthened past an allowed limit, the whole engine had to be pulled from the airframe and rebuilt from scratch. In practical terms, this meant a typical Jumo lasted somewhere between 10 and 25 hours of flight time before it needed an overhaul, and if a single compressor blade broke loose, it could trigger a violent chain reaction that tore the entire turbine section apart. On top of that, American and British air forces were relentlessly bombing German factories. To save their production lines from total destruction, the Germans had to decentralize manufacturing. They started hiding small workshops deep in the mountains and dense forests. Yet despite these severe wartime hardships and constant raids by Allied aircraft, the number of Me-262s rolling off the assembly lines kept steadily climbing. They managed to pull this off by simplifying the aircraft's design to the absolute limit. For instance, wherever they could, they swapped out strategic metals for ordinary wood. This included parts like the landing gear doors, instrument panels, and various covers and fairings. Many parts were churned out using the fastest and cheapest methods available. These methods included hot stamping and casting, and the skin on the wings and fuselage was fastened using standard round head rivets. One of these hidden production lines, given the code name Kuno 1, was strung out along a camouflaged forest road near Leipheim in Bavaria. Components arrived at different points along this makeshift assembly line, and once finished, the airframes were towed out to a nearby stretch of the Autobahn linking Stuttgart and Munich, itself painted over to blend with the surrounding fields, before being flown off to a proper airfield. An even more ambitious scheme converted an old porcelain mine tunneled into the Walpersberg Hill near the town of Kala into a bomb-proof underground factory. Finished jets were hauled up an inclined railway built into the mountainside to a runway laid across its summit. Thousands of forced laborers, many of them concentration camp prisoners, dug and expanded these tunnels under brutal conditions, and hundreds of them never survived the ordeal. So exactly how many of these aircraft were actually built? Historians still debate this. You can find some wildly conflicting numbers in print: 1,294, 1,433, and even 1,900 airframes. The most plausible figure is 1,433 Me-262s. This is especially true if you include the early prototypes. What is staggering is that in just the first 4 months of 1945, camouflaged German factories managed to crank out 865 of these jets. Nearly 500 more airframes were sitting on assembly lines in various stages of completion. These were mostly being assembled at hidden facilities scattered across the country. On top of that, the High Command had ambitious plans. They called for the delivery of 1,000 of these jet fighters to the front lines every single month. This was supposed to happen by the end of 1945. Production of the Jumo 004B jet engines was set up deep underground. It was located inside the tunnel complex beneath the German city of Nordhausen. But the engineers ran into a critical problem. They faced a catastrophic shortage of nickel and chromium. These metals were absolutely vital for creating the heat-resistant alloys needed for the turbine blades in these advanced new engines. This same tunnel complex beneath Nordhausen was better known under another name, the Mittelwerk. Its southern galleries were already busy assembling the notorious V-2 rocket, and the section handed over to jet engine production became known as the Nordwerk. Thousands of concentration camp prisoners, drawn from the nearby Mittelbau-Dora camp system, were forced to carve out and operate this underground complex under appalling conditions, and a great many of them perished there. Germany's most advanced jet engine and its most feared long-range weapon were, in effect, being built side by side deep inside the same mountain by the same starving workforce. One of the early prototypes became the baseline for the future production version of the Me-262 fighter bomber. The defining feature of this experimental aircraft was its bomb racks. They were installed under the fuselage to carry two 250-kilogram bombs. Interestingly enough, this specific airframe had previously been used for something entirely different. Designers were using it to figure out how to lighten the flight controls. They also wanted to reduce the pilot stick forces. To help this heavy aircraft get off the ground faster and shorten its takeoff roll, it was equipped with 2 Rheinmetall Borsig rocket boosters. Each of these RATO units produced over 1,100 pounds of thrust. This practically launched the aircraft into the sky. When the final decision was made in June 1944 to put the UMO 004B engines into mass production, engine deliveries for the Me-262 immediately surged. That same month, the Luftwaffe received its first 28 brand-new fighter bombers. In July, that number grew to 59, but August saw a major drop. Due to a severe engine shortage, they only managed to assemble 20 aircraft. They managed to partially recover in September. This bumped the production rate up to 91 aircraft a month. Overall, by the end of 1944, the Germans had built 513 Me-262s. It sounds like a solid number, but it fell far short of what the High Command had originally planned. A month after being appointed Chief of Staff of the Luftwaffe, Lieutenant General Werner Kreipe tried to get through to Adolf Hitler. He wanted to convince the Führer that the Me-262 needed to be used primarily as a fighter. This was to effectively defend the skies over Germany from relentless Allied bombing raids. On August 30th, 1944, Werner Kreipe finally managed to wring a concession out of Hitler. Every 20th Me-262 coming off the assembly line would be built as a dedicated fighter. But Hitler laid down a strict condition. Even these aircraft had to be fitted with bomb racks. This was just in case they needed to carry at least one 250-kilogram bomb. Based on those numbers, the Luftwaffe was only going to get around 70 dedicated jet fighters. Besides the base model, engineers built an experimental variant. It was heavily armed with two Mk-108 cannons and two 250-kilogram bombs. There was also an ambitious concept for a heavily armored Me-262 ground attack variant. It was designed to pack 4 Mk-108 cannons. The plan featured thick armor to protect the fuel tanks. It would also shield the pilot from below and the sides. However, wartime realities set in. This flying tank never actually made it into production. In mid-May 1944, Hitler made a fateful decision. All Me-262s produced up to that point, aside from a handful of prototypes, were to go exclusively to bomber wings. The Führer was well aware that American and British forces already had total air superiority. He hoped these high-speed jet bombers could punch through the Allied fighter screens and help ground troops hold back the advance. Hitler's greatest fear was a potential Allied landing in France, and his instincts were right. The massive invasion launched on June 6, 1944. Preparing for this, on May 29th, Hermann Göring called an urgent meeting at the Reich Chancellery in Berlin. Top brass was in attendance, including Generals Adolf Galland, Karl Bodenschatz, Günther Korten, and Colonel Edgar Peterson. Despite their fierce objections and attempts to change his mind, the Reichsmarschall issued strict orders to equip only the bomber units with the new jet-powered Messerschmitts. This was exactly 8 days before American and British troops landed on the French coast. By June 3rd, the commander of a group within the bomber unit, KG-51, Edelweiss, received orders to turn in their old piston-engine Junkers 88s. Instead, he, along with his pilots and mechanics, was to immediately relocate to Lechfeld Air Base to transition to the cutting-edge Me-262. The plan called for the unit to be fully combat-ready by August, with the rest of the wing following suit by the fall. But events overtook them. On June 6th, the Allies landed in Normandy, yet the German jet pilots wouldn't see action until late July. That's when 10 of the new jets, led by Captain Wolfgang Schenk, attacked American and British forces along the beaches. But the devastating impact they expected from these jet bombers never materialized. Because these aircraft had no room for a bombardier and lacked a proper bombsight, the pilots had to drop their ordnance purely by eye. This inflicted practically no real damage to the enemy. Command of the unit changed hands during this stretch of the war. Oberstleutnant Wolf Dietrich Meister led KG-51 through its conversion to the jet and through the opening months of combat, before handing the wing over to Wolfgang Schenk that December. Schenk was already a familiar face around the program. A veteran of hundreds of combat missions as a fighter, ground attack, and bomber pilot, he had personally overseen the earlier bomb-dropping trials with the Me-262 back in June, before leading those very first jet bomber sorties over the Normandy beachhead himself. The situation on the front changed drastically on August 12th, when a major Allied offensive began. At the time, KG-51 was operating out of the Étampes airfield near Chartres, but just 4 days later they fell back toward Paris. The squadron operated from there until August 27th, before being forced to withdraw to Belgian territory. From there, on August 28th, the Me-262s launched their first strike against American positions near the French capital. This day was also significant because the unit suffered its first loss. One of the jets, the bomber variant known as the Sturmvogel, was intercepted and shot down by an American P-47 Thunderbolt. By August 30th, the German wing relocated once again, moving to airfields in the Netherlands, specifically around Eindhoven. From there, these high-speed jets were tasked with halting the Allied advance at the strategic Albert Canal line near Antwerp. Allied High Command was heavily concerned about the threat posed by the new German jet bombers. As a result, on September 3rd, the Royal Air Force launched massive preemptive strikes against the 51st Wing's bases. This attack was so devastating that it virtually paralyzed the unit's operations. The Germans hastily withdrew the few surviving aircraft to safer airfields further inland. From there, starting on September 26th, Me-262 pilots carried out bombing runs on a strategically important bridge in Nijmegen, which the British had already secured by then. On the first day of these raids, the Germans lost only one jet to accurate flak. All other attempts by Allied fighters to intercept the jet bombers in the air failed completely. It wasn't until October 13th that RAF pilot Robert Cole, flying a Tempest fighter, finally scored the long-awaited first confirmed aerial kill against an Me-262. At the time, conventional piston engine fighters and Allied anti-aircraft guns were practically powerless and simply outmatched by this new aircraft. The German tactics were simple but incredibly effective. Me-262 pilots usually flew solo sorties to avoid drawing unwanted attention. In broad daylight, they would approach their target at high altitudes over 26,000 feet. They would then drop their bombs while entering a shallow dive and immediately dash back to base at full throttle. For conventional piston fighters, they remained virtually untouchable targets in the sky. Allied commanders eventually worked out a countermeasure of their own. Since the Me-262 was at its most vulnerable during the slow, flaps-down approach to landing, Royal Air Force Tempest squadrons kept aircraft on standby. Ready to scramble the instant radar picked up a jet in the air. Rather than chase the fast-moving target directly, these fighters raced straight for its home airfield, hoping to catch it defenseless on final approach. The Germans answered in turn by ringing their main jet base at Rheinhopsten with more than 150 anti-aircraft guns, creating what pilots on both sides came to call a flak lane. After losing several Tempests to this gauntlet of fire within a single week, the tactic had to be abandoned. On October 1st and 2nd, 1944, these jet-powered Messerschmitts launched devastating strikes against the airfield at Grave near Nijmegen, without suffering a single loss. In this daring raid, they caught the enemy off guard, destroying about a dozen Spitfires on the ground. On top of the lost aircraft, the Allies suffered heavy casualties among both aircrew and ground personnel. The jets, operating alongside conventional piston-engine aircraft of the 3rd Fighter Wing, delivered their most successful strike on New Year's Day of 1945. The target was the RAF airfield at Eindhoven during the massive Operation Bodenplatte, which translates to baseplate. The results of this surprise attack were disastrous. Around 50 Spitfires and Typhoons burned on the flight line. Today, decades after the end of World War II, historians and military aviation experts are careful not to overstate the actual role these jet bombers played in destroying Allied aircraft on the ground. Combat records clearly show that these staggering numbers were mainly achieved due to the element of total surprise. After all, hardly anyone could have imagined that the Luftwaffe would risk such a massive and daring operation right on New Year's Day. So we need to be realistic about this finest hour for the Me-262 and not exaggerate the purely technical advantages of the airframe itself. The Sturmvogel's last significant combat effort came in March 1945, after American troops seized the railway bridge at Remagen largely intact. Desperate to knock out the crossing before the Allies could pour reinforcements across the Rhine, Hermann Göring personally telephoned KG-51 and asked for volunteers willing to dive their bomb-laden jets straight into the span. 2 pilots reportedly stepped forward, though their own squadron commanders talked them out of it before the mission could ever be flown. Over the following days, Me-262s joined Arado jet bombers in repeated conventional strikes against the bridge and its temporary pontoon replacements, flying out of a stretch of Autobahn between Leifheim and Neu-Ulm that had been pressed into service as a makeshift airfield. Despite these efforts, and despite heavy losses to the massed American anti-aircraft guns ringing the crossing, the bridge ultimately collapsed on its own on March 17th, undone by accumulated structural damage rather than by German bombs. However, this formidable weapon had one major design flaw. It lacked a dedicated bombsight for precision bombing. Since it was physically impossible to cram such bulky equipment into the tight single-seat cockpit of a standard Me-262, engineers had to modify the airframe. They completely redesigned the nose section of the fuselage, stripped out the heavy 30mm cannons, and installed a separate compartment for a bombardier navigator. That being said, only a single prototype of this heavily modified variant was ever actually built. This bombardier variant carried the factory designation Me-262A2A/U2. Built from an airframe originally used in early flight testing, it stripped out the fighter's cannon armament entirely in favor of a cramped, glazed compartment in the nose. There, a second crewman operated a Lotfe 7H bombsight while lying flat on his stomach, since the tiny compartment left no room to sit upright. At the same time, German designers were busy developing another variant. It was a high-speed bomber capable of carrying a 1,000-kilogram bomb load. To give the aircraft more range, they increased the fuel capacity by adding extra tanks, bringing the total supply up to 1,334 gallons. If needed, this bomber could be armed with 2 heavy Mk-108 cannons, and it featured underwing hardpoints for carrying rockets. With all these additions, the aircraft's maximum takeoff weight reached a staggering 18,360 pounds. To get such a heavy weight off the ground, they had to install new, significantly more powerful Jumo 004G engines. On top of that, the massive weight meant engineers had to substantially reinforce the landing gear. They planned to fit the main struts with dual wheels and add jettisonable auxiliary gear that would drop away right after takeoff. This unconventional setup had already been successfully tested on earlier variants of the aircraft in a desperate bid to turn the tide of the war.